In today's episode, you'll see China develop a brain chip and implant it in a fully paralyzed man. Now he's controlling robots, wheelchairs, and even working to earn money. Who said AI needed a physical body? Listen to this. Tron 2 selects the form to use in every situation. The head of military intelligence, 6 issues a historic warning. Tech companies may be taking over and editing the course of the world. That used to be the role of governments in the past. Drones that think as one, working together to lift heavy loads, even with wind and instability. Police can now use AI glasses to instantly identify license plates and violations just by looking at cars. Out there on the streets of China, let's try to understand all of this. Hello, impressed viewers. I'm Carlos Alves, and you're watching Amazing Reality. Let's get to the video. What if a robot didn't need to have just one physical body? What if it could choose which form to use before performing each task? In Shenzhen, China, Linux Dynamics unveiled Tron 2, a modular AI robotics platform designed for advanced research and industrial development. Tron 2, unlike industrial robots, isn't limited to one form. It was designed to change configuration according to the mission, offering laboratories a highly flexible testing environment to explore new forms of locomotion, manipulation, and embedded intelligence. Tron 2 can operate in 3 ways. In one form, it becomes bipedal with 2 arms for manipulation. In another, it replaces its feet with wheels. It prioritizes mobility, stability, and load capacity, switching to a bipedal configuration with consoles when needed for stairs or certain terrains. Each Tron 2 arm has 7 degrees of freedom and a spherical wrist for much greater dexterity. The workspace extends to 70 centimeters, and with dual arms, the robot lifts up to 10 kilograms. The response is fast. The teleoperation latency is around 50 milliseconds, practically in real time. In wheeled mode, Tron 2 carries 30 kilograms, navigates uneven terrain with adaptive control, and has automatic recharging. Now, in biped mode, it uses vision-based motion planning to climb stairs autonomously. Safety was also treated as the central element. Tron 2 uses algorithmic limits to prevent self-collisions and hardware damage. In case of a power failure, a dual redundant power system ensures that the arms are retracted to a safe position. The platform unifies vision, language, and action concepts, combining data collection, processing, training, and inference in one environment. The system provides an open software toolkit compatible with Python, Robot Operating System 1, and Robot Operating System 2. It fully supports the real belt, simplifying development in simulators such as NVIDIA, Zaxxon, Mujoko, and Gazebo. Models and algorithms come pre-configured, trained with over 1,000 real data sets with prices starting at $20,000. Tron 2 isn't just another little robot, no, it's a walking laboratory. So, when the roads stop having just one physical body, what will be the limit of all this, huh? Let's wait. And in the future, traffic enforcement won't need human agents stopping you anymore. It'll just be a look to monitor you. That's the future for us, okay? Because Changsha traffic police in China have equipped frontline officers with these smart glasses, which are already in use. Using artificial intelligence, they can inspect vehicles in real time. The equipment was adopted by the Traffic Management Detachment of the Municipal Public Security Department and is already being used directly on the streets, not as an experiment. The glasses seem ordinary at first, just like mine mentioned in the description if you're interested. But they have a built-in wide-angle camera with 12 megapixels and an artificial intelligence stabilization system that keeps the image sharp. Even when the officer is walking or in heavy traffic, the information appears on a small screen in their field of view, allowing the agent to keep moving. The battery lasts up to 8 hours, enough for a full shift. The main feature is automatic license plate recognition, working offline with over 99% accuracy and results in under 1 second. As soon as the vehicle is identified, the glasses connect to the public security database and display the registration, inspection status, and violation history almost instantly. This reduced verification time to only 1 or 2 seconds. In addition, the system includes facial recognition, real-time voice translation into more than 10 languages, and video recordings for law enforcement. Inspections become faster, contact-free, less stressful for officers, and more accurate. It's automation entering our view, technology used for urban surveillance. Another example, right? I don't see it as a bad thing, at least for me. Those who do the right thing shouldn't worry unless the governments are changing. If you look at it that way, surveillance isn't our biggest problem. So pay attention to this next story because things seem to be changing, right? And we've always believed that the ones shaping the future of the world are the governments, their armies, and in some cases, the elections. But what if that's not true? What if tech companies are actually dictating everything? The warning came from an unexpected source. Blay Matreville, military intelligence, Six's new chief. The British Secret Service publicly stated that global power is shifting from states to tech corporations and, in some cases, even to individuals. In her first speech in office, she declared that the world is being actively reshaped, with profound consequences for both national and international security. Matreville says control over strategic technologies has made power more diffuse, unpredictable, and harder to contain. She summarized the current moment as an ambiguous space between peace and war, making it clear that this is not just a temporary transition, nor an inevitable and slow process. This is really already happening. According to her, in practice, what she describes is a structural change. Information technology, digital platforms, algorithms, and global networks have started to influence elections, markets, public opinion, and even foreign policies. Tasks once needing whole states are now handled by global private companies. Information, formerly unifying, is now weaponized. Lies spread faster than facts. Algorithms reinforce prejudices, and hyper-connected societies end up more fragmented and isolated. And the weight of the statement increases when it comes from someone who knows the game of power from the inside. The military intelligence. Six, in case you didn't know. Since World War II ended, it has been involved in many secret operations to influence governments worldwide. When an agency like that, with that kind of history, claims to recognize a hostile takeover, the warning takes on a whole new dimension, doesn't it? For Matreville, technology companies are getting dangerously close to exercising a kind of control that only governments used to have. Interestingly, she avoided naming names or directly criticizing tech monopolies, instead focusing on the erosion of public trust. That reveals a much deeper tension. The warning isn't just about corporate power, but about who should have global control. Matreville, who was educated among the British elite and has a career tied to defending the interests of the state, does not question the system. She vies for control of it. Deep down, the message is clear. The world seems to be changing hands, and if in fact tech companies have too much power in their hands, I ask you, who should run the planet and who gets to decide that? I'm just a mere YouTuber around here. And in previous episodes, I showed some pretty interesting robotic hands here, including one with a sense of touch similar to ours. But this one is, without a doubt, the most impressive I've ever seen. This year, in Shenzhen, OuijiTech officially announced its first product, the OuijiHand, a highly dexterous robotic hand designed for humanoid robots and advanced automation systems. The hand features 20 active degrees of freedom and 4 linked joints per finger. Simply put, each finger can move in a complex, lifelike way, much like a real hand. This architecture enables delicate grips in complex tasks like turning, adjusting, or holding irregular objects. Despite its articulation, the hand weighs under 600 grams and is about 20 centimeters, nearly human-sized. The most impressive fact appears when strength and delicacy meet. Though lightweight, OuijiHand endures up to 10 kilograms of static pressure and delivers 15 newtons at the fingertips, sufficient for industrial tasks. The key difference is reliability. The company says it has tested this hand in over 1 million cycles and ships it after 300,000 factory-standard gripping cycles. It's not an academic lab. It's a product built for continuous operation with real-time response is another key point. The hand uses data feedback up to 1,000 Hz for rapid adjustments, which is crucial for humanoid robots to react to their environment like humans. It also offers various industrial interfaces like USB, recommended standard, 485, and EtherCAT, making integration into different platforms easier. OuijiTech is backed by Modular, a motor manufacturer, indicating a vertical strategy with direct control over actuators, adjustments, and performance. In a market where advanced robotic hands are usually rare and extremely expensive, This combination can be decisive. The artificial intelligence brain is already ready. We've seen it around, and now the hands are starting to catch up. The question is no longer whether humanoid robots will be useful in the future, but when this whole system will be integrated. Doing everything at once won't take long. From what I'm seeing here, the goal of building a much stronger drone in this case has given way to an idea that uses several drones, thinking and acting as one. Researchers at Delft University of Technology in the Netherlands created an algorithm that enables multiple autonomous drones to work together to carry heavy loads, even in adverse conditions such as wind and instability. The technology was created with real and complex tasks in mind, such as the maintenance of offshore wind turbines, as well as construction in remote areas and operations where human access is difficult or dangerous. The idea is simple but powerful. Rather than one drone lifting too much, several drones use cables to connect to the same load. The algorithm synchronizes each drone in real time, adjusting position, force, and direction to lift and keep the load stable. And this, of course, is something essential when working close to structures, obstacles, or human beings. According to researchers, the main challenge isn't lifting the weight, but achieving instant coordination when the load shifts or the wind changes. The drones must react within milliseconds, but traditional algorithms are too slow. The team built quadcopters and tested the system with up to 4 drones simultaneously. They added obstacles, simulated wind with fans, and used an unstable load. In every scenario, the system adapted automatically. You just have to set the destination and the drones take care of everything else. Notably, the algorithm works without load sensors, which is unusual for such systems. It compensates for external forces by monitoring the drone's collective behavior. This makes the technology more practical in real-world situations where installing sensors everywhere isn't possible. Currently, tests use external cameras in labs, but the team is working to deploy the system in open environments, useful for rescue, agriculture, and remote construction. And what if paralysis stopped being a physical limitation and became just a technological challenge? On December 17, Chinese Academy of Sciences researchers announced a historic brain-computer interface breakthrough. A fully paralyzed man interacted with the world using only brain signals, surpassing what Neuralink has achieved so far. The Center of Excellence in Brain Science and Intelligence Technology, Center of Excellence in Brain Science and Intelligence Technology, conducted the work. It marks the first stable, continuous control of multiple real-world robotic sensors using a fully implanted wireless brain interface. The patient, known as OuijiHand, suffered a severe spinal cord injury in 2022, losing voluntary movement below the neck. After over a year of rehab with little progress, he joined the clinical trial for the new brain-computer interface, or brain chip. In June, surgeons implanted the WRS-01 system at Wuhan Hospital in Shanghai. Small, flexible electrodes were inserted into the brain to capture neural signals, connected to a chip embedded directly in the skull. An external device provides wireless power and receives these signals. Within a few weeks of training, Heng was already able to control a computer cursor using only his thoughts, without any physical movement. In simple terms, the brain sends electrical signals, and artificial intelligence interprets these signals and turns them into digital commands almost instantly. But progress went beyond the screen. Heng began controlling robotic dogs to fetch items and used a smart wheelchair to stand upright again, and even move around outdoors, including going downstairs without any help. The technology gave him back a good measure of independence, including the ability to work using only brain control. OuijiHand works remotely for pay. What he currently does is monitor vending machines from a distance. This is the first known case of a brain-computer interface test participant performing a real professional activity. This result brings to mind that idea of so-called telepathy, promoted by Elon Musk and Neuralink, but with a crucial difference. Western tests focus on simple games and controlled demos, while the Chinese system is already used daily, integrating robots, wheelchairs, and real work. This is possible due to a complete ecosystem: advanced AI, mature robotics, fast wireless networks, and semiconductor manufacturing all working together. The researchers reduced the delay between thought and action to under 100 milliseconds faster than our body's natural signal transmission. With continued use, Heng's brain needed fewer neurons for the same control, making it feel more natural and less tiring. With the next version of the system, the WRS-02, promises even more neural channels and even direct speech decoding. It's already clear that we, as human beings, will indeed be able to control machines with our minds, isn't it? But how far can this fusion between the brain and technology go to redefine what it means to be a human being? So, are you interested in this Chinese chip? Or would you rather have Elon Musk's? Or do you not want any of them? I'm fine without a chip in my head. And we still haven't seen brain chip users controlling a drone, for example. But Anti-Gravity has just launched the A1, which doesn't need joysticks, and lets you control it just by using and tilting your own body. Presented as the world's first all-in-one 360K 8K drone, at first glance, it just sounds like exaggerated marketing. But the idea completely changes the logic of recreational and cinematic flying. Here, the vision goggles aren't just an accessory, they were a cockpit. The drone was designed from the start for immersive first-person flight, with motion control using the grip controller and the so-called free motion mode. You steer by pointing where you want to go, using natural hand and head movements instead of joysticks. It's like virtual reality in the real world. You see everything in 360 degrees with no blind spots, and the view shifts as you turn your head. If you tilt your wrist, the drone responds. It's like swapping the joystick for your whole body. As an interface, the system streams live video in 2K with about 150 milliseconds of latency. Noticeable in numbers, but barely felt in practice. Although immersive, the A1 still includes classic safety features like front and bottom sensors, plus a multi-location system with global positioning system Galileo and Beidou. You also get visual alerts when near obstacles. What's especially interesting, in my opinion, is that you record everything simultaneously. The A1 uses two sensors to record 8K video at 30 FPS in a fully stabilized sphere without a gimbal or pre-framing. The logic is simple: fly first, frame later. A single shot allows you to create panoramas, tracking shots, effects, or cinematic scenes in post-production, all without reshoots. All of this changes the relationship between the pilot and the camera. Instead of thinking like a cameraman during the flight, you think like someone who is exploring the environment. Flying becomes the main experience, with recording happening as a form of focus. At just 249 grams, the drone stays under regulatory limits in many countries and flies for up to 24 minutes. Or if you prefer, you can have more using an extended battery. This drone isn't designed for complex maneuvers, but for sensation and presence, letting you rediscover familiar places from a perspective humans can't experience. If you like this episode, leave your opinion in the comments. That way, YouTube shares the video with more people and you help me out with your contribution. You don't need to leave money or anything, just like subscribe, share, and comment if you can. That really helps, okay? It's a YouTube-istic package. Wow, what an ugly term. It even sounds like a curse word. Leave a comment, it really helps me. Thank you very much for sticking with me until now. All the sources are in the description, and you can check them if you have any doubts about anything. So, I'll see you in the next one. Just click on one of the two suggestions on your screen. Before all that, remember, my book is available on Amazon. You can read a little excerpt there, and if you like it, buy it as a gift for someone. Let me know your feedback. That's it for me. Bye.